When you have an integral in rectangular coordinates and you're instructed to change it to polar coordinate integration, you really need to first draw the picture to see what's going on, or else you wouldn't know what to do. So first of all, since you have dy here, these should really be thought as y equals to and y equals. The easier one is y equals to negative radical 3 over 3x. Now this number looks scary, but it's just some number less than 1, and it's minus. So if you view it like y equals to mx, that's a line passing through the origin, right? And because it has a negative and some small slope, it should be a slope that's like that. Okay. On the other hand, if you have y equals to minus square root of 4 minus x squared, then if you square both sides, you get y squared equals to 4 minus x squared, and move the x squared to the left, so you get x squared plus y squared equals to 4. And that's clearly a radius 2 circle. And it's centered at 0, 0. So if you were to draw this, this would be a radius 2 circle. Except that when you try to go back, because of this minus, it's really just the bottom half of the circle. Okay. So you should. So the way you should think is this bottom is given by y equals to negative radical 4 minus x squared. I know it's the bottom because there's a minus. See, square roots only produce 0 or positive, so if you put a minus, that only gives you something that's below the x-axis. Okay, so you have this, and then you want to, let's see, you want to start from here and you end here. So you start from here and you end at some line here, except that your x goes from 0 to radical 3. So your x goes from 0 to radical 3. So it's only over here, from here to there, and then so it's more like you only have this portion of the circle until 0 to radical 3, and it's this line. It's this line. So you start from here and you end there as you paint upwards. See, I know I'm painting upwards because this is dy. Increase in y means you're going upwards. Okay, so you start from here and you end there to get you this area. Okay. Okay, so once you have this, then you want to. So the next thing you want to do is, now how do you represent this into polar equation? Actually, there's one more thing that we should do. We really have to check if this point where the two curves meet is indeed at radical 3. So how would you check that? Well, to find the intersection point, you set them equal to each other, right? So you set negative radical 3 over 3x equals to negative radical 4 minus x squared to see where they intersect. And if you multiply by negative 1 and then square both sides, you get radical 3 squared, which is 3. 3 squared is 9. X squared is x squared, equals to 4 minus x squared. 3 over 9 is just 1/3, and 1/3 x squared, and then if you move x squared to the left, it's plus x squared equals to 4. Let's multiply by 3 just so that we don't have to worry about fractions. So 3 times 1/3 will cancel. 3 times 1 will give you 3x squared, whereas on the right side, you get 4 times 3, which is 12. This is 4x squared, which is 12. X squared equals to 3, and then x is indeed plus or minus 3. except that if you plug in x equals to negative 3 into the original equation, you'll see that it doesn't satisfy the equation. So I mean, sometimes if you have an equation with the square roots, you get something called extraneous solutions, right? And x equals to negative 3 is an extraneous solution, so you throw that away and you only get, sorry, it should have been square root. Okay, you only get positive square root of 3 as the only intersection point. So indeed, the two curves meet at radical 3, and therefore this is the shape that we're trying to integrate over. Okay. Now let's move on and think about how to represent that as a polar equation. So here is what we have. We have a circle of radius 2. It somehow stops and you have this thing here. This equation is y equals to negative radical 3 over 3x. And this would be y equals to negative square root of 4 minus x squared. Or we just found out that this is same thing as x squared plus y squared equals to 4. Now let's try to convert these one by one. To convert this, we use the formulas x equals to r cosine theta and y equals to r sine theta. Another thing that's really handy is that since r is square root of x squared plus y squared, you can square this and get r squared equal to x squared plus y squared. And this surprisingly appears a lot. And in fact, this second one is a direct application. This is r squared, right? So r must be plus or minus 2. So either r is 2 or r is negative 2. Okay. They both give you a circle. R equals to 2 gives you a circle of radius 2. R equals to negative 2 also gives you a circle of negative 2. Actually, of positive 2. Well, think about why this also gives you a circle. But we just need one equation, so we'll just use r equals to 2. Okay, so r equals 2 will give you this circle. So that part is done now. What about this one? For this, you have to replace y by r sine theta. And on the right side, you have x is r cosine theta. You can divide r both sides. Well, you can't do that if r is 0, but you know, this is a line passing through 0, so other than this point, r is non-zero. So if it ever not includes 0, the origin, then we'll have to add that later. Okay. Anyways, that's what we have, and then we can further simplify this by dividing by cosine both sides. So we get sine theta over cosine theta equals to negative radical 3 over 3, but that's tangent. Okay, and then we also find out this means that theta is tangent inverse of negative radical 3 over 3. And tangent inverse is an odd function. Your minus can come out. That's not true for cosine inverse, but for tangent inverse, minus can come out. So it's minus tangent inverse of radical 3 over 3. And if you know that tangent of 30 degrees is equal to radical 3 over 3, then you get that theta equals to negative 30 degrees or negative pi over 6 as this equation. And if you think about it, it does make sense, because if you have theta just equals to negative pi over 6, that's all the points on this line, because all of these points have angle of negative pi over 6 from the x-axis, right? So every point on this line satisfies that theta equals to negative pi over 6. So you can represent this line as theta equals to negative pi over 6, and that's good. However, because you have to start from here until here, it's probably better to have your angle between 0 to 2 pi. So instead of this, we will add 2 pi to get a coterminal angle and get theta equals to, let's see, 11 pi over 6. Okay, so after this hard work, now we have the equations ready. So we have this thing here. So this line here is theta equals to 11 pi over 6. This one is actually theta equals to 3 pi over 2, because that's the 3 pi over 2 angle, right? And if you try to rewrite this into dy dx becomes r dr d theta, don't forget this r. It's really important to remember that r. Okay. And then e to the x squared plus y squared, we just did that. I explained that this is same as r squared, so it's going to be r squared. And if you have dr inside, that means you're trying to paint this region radially starting from the origin, right? So if you try to paint this region radially from the origin, you always start from 0 and you end here. But this equation is r equals to 2, right? So that means r starts from 0 and ends at 2. And your angle theta starts from 3 pi over 2 and ends at 11 pi over 6. And that's it. This is the answer for the change of this rectangular into polar coordinate integration.